Hello everyone, my name is Isabella and my scientific partner is Isabella Carvalho. We both are from Brazil. We represent in this video our high school science project entitled Be Green for a Sustainable Future. Did you know that the cities, despite occupying only 2% of Earth's surface, are responsible for more than 70% of greenhouse gas emissions? And if we continue with the same current partner, the temperature of the planet can increase by 1.5 Celsius. Taking this alarming data, we have to face this problem in a global scale, aiming at the already existing damage to the environment and the human health. During our studies, we could realize that this scenario is intensified by the lack of green areas in many cities around the globe. For example, the city of São Paulo, which is the biggest city in Latin America, has only 11.7% of trees in its entire spatial dimension. However, this number gets worse when we look in different zones of the city, because the green areas in perfect zones are smaller compared to the central ones. Facing all of this problem, the question remains: how to solve it? To propose a solution, the United Nations creates the Sustainable Development Goals, so-called SDGs. They are the blueprint to achieve a more better and sustainable future. They address the challenges we face today, such as inequality, poverty, climate change, environment degradation, peace, and justice. Thus, our project is aligned to the SDGs, and we aim to implement green technologies in peripheral zones via green roofs in already existing buildings. This way, we can contribute to urban sustainability and reduce social inequality.
For this, we structured a solid methodology to accomplish our goals. Firstly, we elaborated a public online survey with 500 people to understand the relevance of implementing green roofs in peripheral urban areas. With it, we found that more than 97% of people believe that there is a need to implement more green areas in the region where they live. Besides, 96% have never seen a green roof in their region. Analyzing the group of people of these 96%, 36% are from central areas, while 64% are from peripheral areas. This statistical data let us conclude the real necessity to implement more green areas in peripheral regions. A major concern we have relies on the type of plants that would be implemented on the green roofs. In the first moment, we start choosing 4 species of stingless bees. To do this, we took into account some characteristics. Among them, choose bee species that were native from Brazil, more specifically from São Paulo, and that were not solitary, since this increases the possibility of pollination of flowers. And choose bees that do not have a stinger in order to reduce the possibility of conflict situations and accidents between bees and humans, since they will be in the same interactive space. After the selection, we filter those has less aggressive defense habits and shows a risk of extinction to contribute in their preservation. This process of choosing bees guided us to the floristic and entomological survey of endemic plant species of Brazil. This survey took into account 4 main criteria. The first one was the selection of plants that these bees would pollinate. In addition, we carefully chose native plants that do not have long roots and show a varied flower colors. This criteria led us to reach a group of 32 species. With these plants in mind, we were able to structure 2 big green ruffles models, one being a horizontal model and the other a vertical one. These 2 models were deeply thought about the design to the material choice, resulting in the schematic draw of them, as well as an evaluation of the pros and cons related to each one. To illustrate, the horizontal model has larger dimensions, being more appropriated for plants with long roots. The vertical model, on the other hand, is more suitable for smaller and more delicate plants species, thus supporting a lower weight and shallow roots. In this last model, we also have the option of distributing plants according to the need for water and adequate sun availability. Regarding the use of water, as it has the capacity of larger layer of land and larger plants, the horizontal model makes more use of water than the vertical model. Even so, both have the possibility of collecting excess irrigation water and even so rainwater, which can be stored and reused later. Our idea beyond these two models is to make unnecessary they use the 7 layers present in the commercial line green roofs. This would be possible since the exits of water will be stored, and this will happen via interconnected pipes in the models. Besides, the irrigation will be automatic in both cases, making the residents' obligation to take care of the models less and control the water flow. Now about the experiment. In the first moment, we opted to test the functioning of the general green roofs via a homemade method. So we carry out experiments using 2 prototypes of cement buildings. They differ in terms of vegetation cover. While one has a potted place off, the other has only a bare cover surface. In this way, we're able to verify the green roof thermal and acoustic reduction features, as well as a better ability to drain water. As expected, the green roof building performed better in these topics. In the other words, we observed lower temperatures and acoustic insulation effect, and the ability to drain up to 70% of all water.
We could notice challenge during the execution of our high school science project. The first one was the fact that my scientific partner and I live in different states in Brazil. Although it was a good thing to integrate our different work perspectives, it was also very challenging to make all the decisions and meetings about the project completely online. Once it was our first experience doing a project in a way remote. But later we could learn how to devise tasks and organize our meetings to make our project succeed. The second challenge was the 3D drawing of our green roofs prototypes, using Blender software to do so. We had to make online training to be able to use the software and transpose our ideas to the online version. We also took a lot of attention to the measures of our prototypes. This way, we could bring more refined features to our scientific work and be more intelligible with other people. In conclusion, our project contributes to 5 of the SDGs, the SDG 3, 10, 11, 13 and 15. On the other hand, it's worth mentioning that our project is still in progress. So, as future perspectives, we have the realization of partnerships with municipalities and NGOs, and besides, we want to test the functionality of the modules in a real building. We would like to thank our advisor Bruno, Navarro and co-advisor João Pereira for their support during our scientific research. They help us with such dedication and affection that we're extremely grateful for. We also would like to thank the architect Lara Jimenez for the help in during our construction of the big green prototypes, and entomologist Ana Quest for the contribution collaboration during the BIS research. Finally, we'd like to thank the Social Institute to motivate, support and recognize talents SMART for the support and encouragement of our academic and scientific life, and also the School Santa Américo for the financial support. Thank you all for your time and attention.